Since it took us so long to save today, I wasn't able to record the very last part of it during class. So I'm going to do a quick review of what we did in the last 5 minutes of class. You'll notice where we left off the problem when the video finally ended. We were down to having these 3 different quantities here, and you'll notice that 2 of them are both natural logs with a 3/4 in front of them. However, I wanted them in the order with the positive one first and the negative one second. So that's what these blue and white arrows are doing down here at the bottom. It's switching it. I also pulled the 3/4 out front, but I ended up with the natural log of 2x minus 3 in front, then subtracted the natural log of 4x plus 1. The fraction 1 over 4 times 2x minus 3, I moved to the back just to separate it from the natural logs. Once I did that, then I was able to take the 2 logs that are subtracted and turn it into division, which is how I got the 2x minus 3 over 4x plus 1. And then finally, we reverse plugged the 3/4 up, so it became an exponent on that absolute value. The rest of it stayed the same. I'm not sure whether the book will go ahead and distribute the 4 on that fraction to make that 8x minus 12, or whether we'll leave it that way. Okay. Finally, then, I didn't have time to work a 3rd problem, but I did want to give a few tips or reminders about what to do. If you look at the start here, the top of the page, if you started out with a problem where your denominator was quantities that contained x squared, in that case, then, we had, when we set up our initial partial fractions, if that's 4x squared plus 1, then the numerator had to start 1 power less, so we started with ax plus b and cx plus d. Okay, what I wanted to really get to, though, is what do you do after you've solved for a, b, c, and d using primarily elimination. This problem turns out that the a and c turn out in this problem to be 0, and you actually only end up with b and d being numbers. So that's why, and they did not turn out to be nice numbers, they ended up to be fractions. So that's how, after you've solved for the partial fractions, I ended up with a 1/3 on top. My question is, did you remember how to integrate 4x squared plus 1? You got squared terms here. You can't substitute the entire denominator because you're going to end up with a 8x, and there's nothing on top to cancel with. So you have to remember, and the class did notice this, that, oh yeah, if it's something squared and it doesn't have a root on it, it must be something like when Juliet is tanning, and so yes, they're inverse tangents, and you're going to see quite a few of those in these problems. If you'll recall, what you needed, if you move down to the next line, I pulled the 1/3 out front. What you need is it to be u squared plus 1 on the bottom, so it looks like the inverse tangent rule. But to make that u squared, you have to ask yourself up here on the 4x squared, what is it that I'm squaring to make 4x squared? Well, I'm squaring a 2x, so therefore I u substituted for 2x off to the side, which means du is just going to be 2 dx, and I brought that over down below. The 1/3 out front with the du over 2 is going to make a 1/6, and then the rest of what's left is inverse tangent of u. At the end, then, you can substitute that in, and you can make that become 1/6 inverse tangent of 2x. And that part would be finished. If you go over here to the second part, it's similar, except this time you have x squared plus 4. To be an inverse trig function, you can't have a 4. It has to be x squared plus 1. So the first thing you have to do is you have to get that 4 to become a 1. So what we did is we pulled a 1/4 out, the 4 out of the bottom, but by pulling 4 out, it made me get an x squared plus 4 here. Once again, I want that to become u squared plus 1, so I had to ask myself, what am I squaring there to make that become x squared plus 4? Well, that's x over 2. So therefore, we u substituted off to the right here, we u substituted for x over 2, which meant our derivative was a half dx, and I would get dx times 2 du. So when I go to substitute that in, I would have 1 over u squared plus 1, and that would be times 2 du. The 1/4 and the 1/3 on top made a 1/12. And so if I was to actually finish that problem then, I'd pull the 2 out front, which would make this a minus 1/6, but that I would now have another inverse tangent of u here, which I could then go ahead and change into a minus 1/6 inverse tangent of x over 2. And then if I pull down what I originally solved for on the right, I have a 1/6 inverse tangent of 2x, and there would be my solution. So beware, if you've got x squared plus a number on the bottom, you're going to see a lot of inverse tangents. You're not going to see inverse secant and inverse sine because they require you to have roots, and you're not going to have roots in the middle of partial fractions. So good luck with these problems and enjoy. Wednesday is another day to work on projects. However, math matters are going to be due on Friday since you don't have any other homework. So make sure you pick up your math matters.